Let's take a look at homework 10, where we're looking at the scope of variables. And the variables could be either instance variables, variables that are a direct member of an object, or at local variables, variables that are local to a particular method. So let's start off with problem 1 here. And in this problem, we start off at the test apples class, which has a main method. You always start with the first instruction of main. And that's going to create an apple tree object and reference it with this app reference here. Let me scroll this up a little bit so we can see the bottom part of this problem here. So first instruction creates the reference variable app, and then it creates also a new apple tree object. And an apple tree object has this instance variable apples. It has the value 53 in it. And it also has these three methods: drop, grow, and report. And if we look at the next instruction of main, we have the app reference, dereference it to the grow method. So we come down to grow here. Grow, if we look, has two instructions. The first one creates a brand new local variable, apples, same name as the instance variable. In general, a bad programming practice, but good for testing your knowledge of scope, the scope of variables. Anyways, then it says we want to print out to the console the words grow C's. So we're going to print grow C's to the output. And then a colon and whatever it sees for apples. So this instruction is looking for an existing variable apples. If first, and there's two of them to choose from, either this one or this one. It can actually, it's within the scope of both of those. An instruction can directly see a variable if both that instruction and that variable are in the same set of enclosing curly braces. So this instruction and apples here in the same set of curly braces, and then this apples variable here, they're also in the same set of curly braces here. So it only can reference one at a time, and it always will see, in the case of a conflict, like we have both of them we can see here, the instruction will always see the closest possible one. So it's going to see this variable apples declared in the grow method. So that 70 is going to get reported. Then we return back up to where we're called, which is here. When you leave a method, its local variables actually disappear. So that apples variable to 70 is gone when we come back up here. And we move on to report method, come into it. It does not declare any variable methods or variable apple variables. So this method, when it's looking to print out the contents of the apples variable, can only see this apples variable up here with the 53 in it. Even if this variable apples here still existed, that was created here, this instruction is not in the same set of enclosing curly braces as that one. So it's impossible for that one to look into that area. So anyways, the output here would simply be grow C's is 70 and apples 53. Then problem number 2, we have again a main method that's going to call several methods in the apple tree object. And let's see if we can get everything on the screen at once here. Pretty close. We're going to first declare this apple tree object with the app reference. I'm going to scroll that off so we can get the rest of the problem on the screen, hopefully. And so let's visualize that. So the first instruction after creating the object is app.report. So we're going to come down to app.report and call the instructions there. And that one says simply print out the word apples. So our output is going to show the word apples. And then whatever it sees for apples, we're down here, no local variable. So it can either see its own local variable or the shared variable up here. So it's going to see that 53 since there is no local variable. And then we're going to come back up here, call the grow method. So we're going to jump into grow. Grow creates its own variable apples, has a 70 in it, and then it prints out grow sees. And again, this instruction here that's trying to print the word or the value of apples. You can see both these variables since it's in the scope of both of those. And so it's going to print the closest possible one, so it's going to print that 70. Return back up to report. Report's going to come down and print apples again. And it still can just see this 53 at the top. Then we're going to call drop. So we're going to jump into this method. This method does not create an apples variable. It does use an apples variable, or it just assigns a value into an apples variable. Since it doesn't have its own local copy, that 11 is going to get assigned into the one up here. And then it's going to print drop C's. And that 11 that it sees up there. And then it returns back to where it's called, moves to the next instruction, calls report yet again. This time, report is going to print the word apples. And then when it looks up a value for apples, again, doesn't have its own local copy, so it looks up here and sees that newly assigned 11 up there. And just as a little bit of review, the reason this line creates an apples variable and this one does not, because this one's a declaration statement, because it declares the type of the variable and then creates it. This one's just saying I'm using the existing apples variable. Let's look at question number 3. And again, we're going to create an apple tree object here. And manipulate it, call its methods. This problem is pretty similar to some of the previous ones, but one notable difference is in this one we're not declaring the apples variable here, and we are declaring an apples variable here. So that's going to affect how this program reports the values. So we start off by calling grow, and so we go down to grow, and it says find an existing variable apples and assign the 70 into that. So we're in grow, don't have a local variable to assign into, so it assigns a 70 up here, and that prints grow C's apples. So there's grow C's, and then again it's going to print the 70 for apples. Return back to where it was called here, and then we are going to call the drop method, so it's going to jump into drop, which is here. In this case, we are declaring a variable, so create a variable apples, assign it an 11, and after we've done that, then we're going to print drop C's, and it looks, so this instruction drop C's, system.print line drop C's, when it's trying to print apples, it can see this local copy right here, so it's going to print that. Then grows returns back up to, or drop returns back up to where it's called here, and calls the report method. So we're going to jump down into report, and it's going to print the word apples, and then look up the value for apples. Again, no local copy, so it's going to have to look to this common copy up here, which is going to have a 70. This one, for a little variety, uses a different class it's creating. So this one's called a class method practice. And first instruction in main here creates the reference variable MP, creates the method practice object, and what that creates is first an instance variable X with a 20 in it, and also creates two instance methods, start and other. And again, in object-oriented programming, you can either call this thing an object, or you can call this thing an instance, as in this object is an instance of the method practice class. And so that's why these are called instance variables and instance methods. First instruction of main after creating the reference and object is take the reference MP, dereference it. I follow the reference and call the start method, which is here. Here's the start method. It doesn't create a variable x, but it does assign a value into an existing variable. So it's going to take the value 33 and assign it over the top of that 20. It's going to then say start, our output is going to say start x, and print the 33 that's currently in there that sees up here. And then it calls the other method, so it's going to jump down into here. And other is going to print out the word x. Again, it doesn't have its own local copy, so it's going to look up to this 33 that's up here. Then other's done, so it returns where it's called, which is here. That's the end of start, so it returns back to where it's called is here. That's the end of main, so the program is over. And here's a similar problem, but a few little variations in this one. Namely, we create a variable x here instead of simply using it as in the previous question. So here's the reference MP to a method practice object. MP is referencing this object. Start off mp.start, so mp.start, come into this method here. First creates a local variable x, assigns a 33 to that. Then it prints out start x and looks up the value currently in x. You can see both this x and this x, but this is the closer one here. So it's going to print the 33, calls other. Other prints out x colon, and looks up the value for x. Doesn't have its own local variable. It can't see, even though this variable is still active, since we haven't formally exited completely from the method start, we can't see that variable because we can see this instruction can see any variables declared here inside this set of enclosing curly braces, and it can see, since it's inside this set of curly braces, which is also encloses this x, it can see that one. So it's going to see that 20 up here and report that. And then again, we're done with others, so it returns back to start. We're done with start, so it returns back to main. We're done with main, so it returns to the operating system and ends the program. Let's take a look at this one. Here we create our MP reference, our method practice object, x with the 20, start and early methods, and start off by going to start, creates its own local variable x here, puts a 33 into that, calls early, jumps down to early. Early doesn't have its own local variable, so when it's adding 100 into x, it's adding into this one up here. Prints out x, and then looks up and sees the 120 in there. And then returns back to where it's called, which is here. There's still another instruction to perform in the start method, so it prints out start x, and then looks up a value it sees for x. Since that instruction is being performed here, it can see this value 33 here. It's going to report that variable x. X is 33. And then we're done with this method, start, so return back to where we called, which is here, and we're done with main. I believe this is the last question in this homework. And so we have a reference variable MP, an object of type method practice, an instance of method practice, and a couple of methods, start and later. And just glancing ahead, we can see we're declaring an X variable here. We're not declaring one there, and we are declaring one down here in later. So now let's follow through the code. mp.start takes us down to here, goes up and replaces this 20 with the 33, prints start X, and we're right here, so it has to look up the 33 here. Calls later. Later creates its own variable X with the 44 in it, right here. Then prints out X is 44, importing it from that spot there. Returns back to where it's called, which is here, and then calls system.println, prints after X, and looks up a value. This instruction is here in start, doesn't have its own local variable, so it picks up the 33.